Hello guys, how are you? I hope you're doing well. Today we're completing the solution of paper 3, theory for car number 32, February-March 2024. I believe in the first part we finished until question 4, as I remember, right? We reached here question 5. Okay, so let's start. The question says the figure 5.1 shows a metal container used for storing petrol. There is some petrol gas above the liquid petrol inside the metal. Okay, so here I have gas and down here I have liquid. Okay. The question says in A, describe the arrangement and the motion of particles in the liquid petrol stored in the container. Okay, so we have to talk about two things, the arrangement, okay, and the motion. First of all, let's talk about arrangement. Arrangement, it's actually, it has a random arrangement. Okay, arrangement, this is M. It has a random arrangement. Basically the particles, they don't have like a specific shape. You can say they don't have a specific shape. We can say the particles are a little bit close to each other. Particles are close to each other, but not as solid. Okay, they are not close as solid. So this is regarding the arrangement. Regarding the motion, we can say that the particles move also randomly and freely. Okay, they move around randomly. I can say particles move around freely. Okay, or also I can say randomly. Another thing, I can say that the particles collide. Particles collide with each other. And of course with the walls of the container. Okay, I can write only one idea regarding the arrangement and one idea regarding the motion, but here I'm giving you many options. I hope it's clear. Now they say in part B, the temperature of the gas petrol inside the metal container increases. The temperature increases. State and explain any change in the pressure of the petrol gas on the metal container. So I have to mention how the pressure will change and why. Of course, the pressure increases with the temperature, right? Pressure increases. Okay. Why the pressure increases? Basically because when the temperature increases, the particles will have more kinetic energy. They're going to move faster. Okay, let me say particles will have bigger kinetic energy, and higher speed. This means that particles will collide, so they collide more. There will be more frequent collision. Okay, they collide more, of course, with each other and with the walls of the container, and also the collision will be not just more frequent, it will be harder. Okay, they will collide more and we can say harder. Why harder? Because since they are moving at a high speed or at a higher speed, the collision will be harder. Okay. Now they say describe how the thermal energy travels from the sun to the petrol inside the metal container. Let's go to the diagram here. Pay attention that the heat comes from the sun using the sunlight. So there's here I have radiation. Okay, radiation. Then they hit the metal container here. The metal container is made of metal, which is solid, so it is conduction. Here is going to be conduction. So there will be two methods of heat transfer. Here is going to be radiation through air. I can say radiation through air, and conduction through the container. Okay, I hope it's clear. Through container. Pay attention, it is 2 marks, so I have to write 2 ideas. I hope it's clear. So this was question 5. Let's see question 6. In question 6, they say figure 6.1 represents a transverse wave. They say determine the amplitude. Remember, amplitude, it is the height of crest. All this is amplitude, which is basically the same as this, which is the same as this, which will be also the same depth here and the same depth here. So amplitude, it is the height of crest or depth of trough. How much is it? It is 30 millimeter. It's written in millimeter, so 30, as we can see. Of course, no need to take the sign. Okay, we only take the absolute value. Okay. Now they say determine the frequency of the wave. We all know frequency is the number of waves per unit time, right? It is the number of waves per unit time. So here we choose a period of time, let's say for example until 0.20. okay, this is the time. So we see how many waves I have until here. Okay, so let's count. We start from the top here, from the beginning. So from a crest to a crest, this is 1 wave, 1 lambda. Okay, again from crest to a crest, another crest here is going to be another lambda. So I have 2 waves in the time 0.2 seconds. Okay, so in general I say that frequency equal the number of waves over the time given, which is 2 over 0.2 or 0.20, the same. Okay, when I divide them is going to be 10 hertz. Okay, the unit is hertz. I hope it's clear. In part B, they say state the name of one type of transverse wave. Transverse wave, we have, let's remember, electromagnetic radiation, right? This is one example. We can say waves in water. We can say waves in ropes, right? We can say also secondary seismic waves. Okay, we all know these examples. Okay, so here electromagnetic radiation, which basically the light, right? So all these are examples. In the second part of the question B, they say describe the vibration in transverse wave. So this is the definition of transverse wave. Pay attention, it's 2 marks. Remember, in transverse wave, the vibration of particles will be perpendicular to the direction of wave. So this is a transverse wave. Okay, so the vibration of particles is going to be up and down, here and here, etc., etc., right? And the direction will be going there. So there is a right angle between them, here and here and here. So we can say vibration of particles, sorry, this is not writing, okay, of particles. Why isn't it writing? Okay, just give me 5 seconds. Okay, of particles is perpendicular, perpendicular means it has a right angle, right? Perpendicular to the direction of wave. We can say perpendicular to the direction of energy, or the same thing. I hope it's clear. So this is question 6. Now question 7. Question 7 says, figure 7.1 represents an object placed close to a thin converging lens. The scale for the grid is shown. Okay, I have the scale here, 5 cm, 5 cm. So this is the dimension of each square. They say here, determine the focal length of the converging lens. Pay attention, please. It is here 2 marks, so I have to write 2 things. So focal length, we all know it is from the, it's the distance from the center here until the distance to the focal point. They need focal length. So focal length, it is actually 2 squares. I have this distance plus this distance, so I can say it is 5 plus 5 equals 10 centimeter. Okay, mister, if I write only 10 centimeter, you'll get 1 mark. Remember, it's 2 marks, as you can see. Okay, so I have to write 2 steps or 2 ideas. I hope it's clear. Now they say, let me choose this color. Okay. Now they say, on the figure, determine the position of the image, okay, formed by the lens. How is that? By continuing the path of each ray beyond the lens. Then use an arrow to indicate the position of the image. Okay, so here I have 2 rays drawn. Okay, remember the ray that comes here, which is parallel to the principal axis, it will refract through the focal. Oh, sorry, I don't have a ruler here. I'm gonna depend on my hand only here. Come on, God. Okay. Good. Approximately, it's a straight line. Okay. So it will refract through the focal point. The second one, let me change that color. The second one, it comes from here through C, and then it completes. Okay, it completes without any refraction. Okay, it comes here and it completes without any refraction after the lens. So they meet here. Okay, they meet here. Where's the image? Is going to be here. Let me draw it with a black color. Okay, the image will be right here, and we put the arrow like this. This is the image. Okay guys, I hope it's clear. What else they say? Okay, here the figure 7.2 shows the regions of the electromagnetic spectrum. One region is unlabeled. State what is it. So here I have between ultraviolet and gamma, we all know it is X-ray, right? Okay. Describe one use of the ultraviolet radiation. I hope you all memorize the use of some of the electromagnetic types, okay, or waves. One application we can say sterilizing food and medical equipment. We can say security marketing or something. Okay, we can say also checking if the money is fake or true. Okay, so basically we use any of these. Okay, let me say security, marketing, etc., etc. You just put one of the uses. Now they say describe a harmful effect on people due to excessive exposure to ultraviolet light. Actually, it has many harmful effects. One of them could be causing cancer, or maybe leading to cancer. It can cause some eye conditions, problems. Okay. Sometimes it can affect the skin, the eyes, the cells. Okay, so we can say it affects skin or eyes, etc., etc. They need only one. So this is question 7. I hope it's clear. Let's do question 8. It's very simple. They say in figure 8.1 shows a permanent bar magnet. Okay, they say describe an experiment to identify the pattern and direction of the magnetic field lines around the bar magnet. You may draw on the figure as a part of your answer. Okay, so basically, how can we determine the direction? Basically, we can use a compass. Because the pointer of the compass will give me the direction of the magnetic field. Okay, if we go here to the magnetic field, okay, if we use a compass, for example, here, okay, the pointer will be almost like this. If we use it here, it's going to be like this, right? If we use it here, it's going to be approximately like this. So basically, we can use either one compass and move it around, okay? We can say, move the compass, move the compass around the magnet, and draw the pointer, of course, at each position. We draw the pointer at each position. Okay, after that we can connect the labels that we drew. For the pointer. Okay, in this case I will be able to draw the magnetic field around the magnet, and of course the pointer will give me the direction. Okay, we can say pointer of compass gives the direction. We all know it is from north direction. It goes from north to south. Okay, after that you can show that you are connecting between them. Okay, and show the arrow like this. Okay, or maybe you just show the arrow on the pointer. Okay, etc., etc. I hope it's clear. Now they say in B, state a name for a material that is suitable for permanent magnet. In permanent magnet we use steel, right? Permanent magnet, it is a magnet that stays magnetized for a long time. Okay, now in C they say state one use of the permanent magnet. Basically it has many uses. We can use it in loudspeakers, for example. Okay, we can use it in some alarms, we can use it in electric motors. Okay, we can say loudspeakers. Okay, as we said also, electric motors, they only need one. Okay, I hope it's clear. Please feel free to ask any question. We will complete the other questions in the next part. Okay, have a nice day. Bye bye.